Good evening, guys. Kamusta na kayo? Okay, to be honest, this is my third try to record for asynchronous lesson for digital transmission or modulation. I do not know what happened to my computer, but anyway, it's better be done than being late. It's better late than never. Anyway, so, okay. So ako ay naka-share na, recorded. Okay, so labas tayo rito. Punta na tayo sa PowerPoint. Okay. All right. So this will be our second to the last lessons. The last will be the satellites. Now, you will notice that actually we already done with our lecture. These are just supplementary topic, and I do believe that we need to at least to have an opener regarding the digital transmission. Okay. Although in ECE department, which I belong, this discipline has a prerequisites, which is the printcom, and then you have your digicom, and then you have your antenna. So there's a lot of basically 8 communication subjects. No, but I do that. There are people that I personally know there. There are electrical registered engineer, electrical engineer registered REE, and yet they are working in a broadcasting station. Okay. In telco. Okay. Parang may nakausap lang akong dati-dati ang sa AsynCHro, kukunti ang mga TUP dyan. Diyan pala sa AsynCHro, isa lang tinatanong, if you know one web programming, even SQL, even PHP or basic, SQL basic na yan, web programming, you are in. The same thing with communication. You cannot learn everything, but it's important you know the foundations. Okay. So this is it, Panzet. All right. So digital modulation or transmission, okay, or com. Now, one reason why we have to study logic circuits, because the higher logic circuits, the latter part of that subject is about ADC and DAC. Okay. And what I have noticed is, why is it that the books authors started with digital to analog? Samantalang the order is he started with analog, di ba? Okay, ako magsulat. You start with analog. You start blue. Okay. With analog. Ayan. And then you convert this one into digital, di ba? Yan naman yun eh, clock. Yan. 101 001. Okay. All right. But this actually the content of the analog to digital, sabi nga ni Ronald Tosi, book on computer systems, that we have to start with digital because the content of analog to digital is digital to analog. Kaya nagsisimula tayo rito. Okay? Okay, kulay, and kung dilaw. Okay? And nagsisimula rito. If you know digital to analog, you know the whole process of analog to digital. Okay? Why we have to go to digital to analog? Simply because because the digital signal can be transmitted directly at baseband. Oh, iba na kulay. Lagyan natin kulay. Maganda rin. Maroon. Ayan. And only under limited conditions. Well, siyempre, sa simula lang naman yun eh. Pero as we go along with the technology, after a certain technology dies, another one improves. What's the weaknesses of the basic one will be the strength of the version 2. And the weaknesses and threats of version 2 will be the strength of version 3. Ganun na naman ang technology. Okay. So for wireless RF transmission, some form of modulation is required to shift spectra. Kaya meron tayong shift keying, phase shift keying, amplitude shift keying, because they saw that it is possible to convert them into digital and then to avoid too much error. Now, in digital, the noise here, we call it error. In analog, the noise is noise. Okay? The key concern are bandwidth efficiency. Yeah. Bandwidth efficiency and implementation complexity. Kasi apektado sila ng pulse shape. Yan. Kasi if this is being, tawag dito, disturbed by unwanted signal, which is error or noise, nagbabago na yan. Apektuhan siya. Kaya we have pulse recovery. Then we have the transition from 180 degrees, 1 to 0 or 0 to 1. And then the fluctuation. Ito pala yung fluctuation. Ito yung fluctuation. So we all know that in a transmission medium like coax, coaxial cable, coax, hirap pagsulat. Coax, X, coaxial, Dalawa naman ang klase ng ating kable, di ba? Basically, we have the flat wire, the coax, and then it was improved by fiber optics. So the bandwidth is a property, which is actually, we've been discussed this already during the AM and FM. The low pass and high pass band. Or low pass frequency and low sideband and upper sideband and the carrier. Okay, these are your bandwidth. Now, example, if we have a spectra from 1K to 2K, so 2 minus 1, we have 1000 hertz. So a medium can pass frequency from 3 to 4. So a bandwidth of 1000 hertz. Can this be signal passed through the medium? Of course not. Because the signal can have the same bandwidth of 1000 hertz. The range does not overlap the 3 to 4 allotted. Okay. Now we all know this, the low pass and the band pass. Okay, because it has a role in digital and analog as well. So in digital transmission, low pass filter, low pass channel. But in analog, especially in station to station, so we have the band pass. So what is the difference type of digital? Ito yung mga ASK, FSK, PSK, and QAM. So it started here. This started on us, and then they just evolved, and then until we have now the latest fifth generation, the QAM. It is a combination of us and PSK. Yan. So allow me to introduce to you the bit rate in digital transmission and the baud rate as well. So bit rate is the number of bits per second. Baud rate is the number of signal per second. So baud rate is less than or equal to a bit rate. So at the end of this PowerPoint, we will see that the baud rate is can be equated to bit rate at the start of a basic less than there's a certain portion, and then as we go along with the QAM, no, nagbabago na sila, magkaiba na sila. Like this one, no? If the baud rate is on binary digits, no, remember that bit is an acronym, stands for binary digits. Now this is the baseband, the basic baseband, where baud rate and bit rate are equal to n. For 2 raised to 2, okay, 2 raised to 2, so you have 0, 0, 0, 1, 1, 0, 1, 1. So you have the bit rate is 2n, the baud rate is still n. Okay. And then for tri-bit, 2 raised to 3. So 8 combinations from 0, 0, 0 to 1, 1, 1, 1. And then for the quad bit, 2 raised to 4, 16 combinations. Well, all of them has the baud rate of equal to n, and the bit rate is increasingly. Okay. Ang kasunod dyan is pentabit. Now, 2 raised to 5, we have 32 combinations. And then hexabit, octabit, nanadbit, and ano ba yung 10? Ano ba yung 10? 2 raised to 10. Anyway. And we have another example here now. We have an analog signal carries 4 bits in its signal unit. Okay. If 1,000 signal units are sent per second, find the baud rate. The solutions, of course, no. So 4 bits, so multiply mo ng 4, so we have the bit rate of 4,000 compared to 1,000 baud rates. The bit rate of a signal is 3,000. If each signal unit carries 6 bits, so divided by 6, so you have 500 bauds. Okay, so by waveform, so you'll notice amplitude shift keying from a smaller amplitude, that is logic 0, okay, to a higher amplitude, so you have logic 1, okay, so you have 0, 1, 0, 1. So this is a baud rate with a bit rate of 5 bps, okay. So 1, 1, 0, 1, 0, 1, 0. Okay. So that's the simplest and most common form of ask. Okay. So what's the relationship of the baud rate and the ask? Now this is our hypothetical way of showing the relationship. Okay. So baud rate, the bandwidth, you have n. So the bandwidth in AsynCHro. Okay. So the lower, which is fc minus n baud divided by 2. And on the other far end, we have fc plus the n baud divided by 2. Okay. So this is your one way to relate baud rate and the bandwidth in ASK technology. Find the minimum bandwidth of an ASK signal at 2000 bps. The transmission load is half duplex. This is an half duplex. Okay. So if it's a half duplex, so the minimum bandwidth is 2000 hertz. Okay. As we defined before kanina, di ba? So in ASK, the baud rate and the bit rate are the same. Okay. An ASK signal requires a minimum bandwidth equal to its baud rate. Therefore, it's 2000. Okay. About this one, 5,000 for an ASK signal. What are the baud rate? Okay. It's still the same in ASK, but because the baud rate and the bit rate are also the same for us, the bit rate is 5,000 bit per second. for a full duplex. Ayan. Pag full duplex, dalawang pares na. Now, can we recall this? Full duplex, pag half duplex, yung ginagamit ng radyo ng mga gwardiya, half duplex yun. Yung cellphone nyo, that is a full duplex. So find the carrier and the bandwidth of its directions. Okay? Ganyan yun. Ganyan ang full duplex. Okay? So for full duplex, the bandwidth is 10,000 divided by 2. So you have 500 hertz. And the carrier frequency, so 1,000 plus 500, 5,000 divided by 2, 3.5 kilohertz to 8.5 kilohertz. Ayan. Okay. Okay. So basically, ask is susceptible to sudden gain. Inefficient modulation technique on voice grade lines up to 1200 bps. Used to transmit digital data over optical fiber. So may optical fiber na rin doon. So happens sa Pilipinas, no, during those time, masyadong sinusulit ng PLDT kanilang copper coax, no? Not like in America. Ma-break even na, they will change the technology in the infrastructure from coax to fiber. And I believe during this time, no, gumagamit na sila dito ng ano, ng yung facsimile, no? Na pwede ka mag-send ng picture, i-scan, tapos at the same time, through, no, to line, this line, message mo na siya. But this is now a frequency shift key. You will notice, from 0 to 1, no, nagbabago yung frequency. Siguro from 5 hertz to 10 hertz, something like that. No? Nagda-double. Okay. So if you have 01101 for a build rate of 5, so the bit rate is 5 bps. So ganyan kanyang representation, guys. So FSK. Okay. So ano ba features ng FSK? As I told you, since this is a digital, hindi na tayo gagamit ng noise. Ang tawag na ngayon ay error. Mas okay siya. As I told you, siyempre yung life cycle ng ASK, na-improve yan ng FSK. O, dito na lang, nabuburi akin. Yung life cycle ng ASK, napaltan siya. Kasi nga mas mabilis siya, mas ano sa noise, no? Sa error. Tapos ang kanyang frequency is from 3 to 3 megahertz. Ayan. Kaya dito nagsimula yung local area network. LAN. Okay, local area network. So that is the hypothetical representation of the bandwidth of FSK in relation with baud rate. Sample. Find the minimum bandwidth for an FSK signal transmitting 2 kilobit per second. Transmission in a half duplex. Ito half duplex yan. And the carrier are separated by 3,000 hertz. Okay? So ito yung mga formula natin. Baud rate o bandwidth. Bandwidth is equal to baud rate. Okay. And bandwidth is equal to baud rate plus FC1 minus FC0. Or bandwidth can be equate to bit rate plus FC1 to minus FC0. So 2K plus 3K, we have 5K. So your bandwidth. The minimum bandwidth for this is 5,000 hertz. How about for a full duplex? Okay, hindi na pinakita. Doble yan. Full duplex. So the bandwidth of the medium, if the bandwidth of the medium is 12,000 and the difference between the two carrier is 2,000. Okay, so 6,000. So 6,000 divided by 2 minus 2,000, we have 4,000. But because the baud rate is the same as the bit rate is 4,000. Okay. Dito na pumasok yung during the time, no, we have already now the mobile phone. No, kasi laki ng portfolio ng bag o 4 na libro. No, ganun kalaki. At ganun kalaki mga battery. Kaya sa malaki because of the battery bank. Because of the battery. Tapos it was modified to a handheld on which you can, the battery is smaller, as big as your meron ako yan ng gawa na Alta Cryptel, no? Na my sister gave me that kind of cell phone during those time. Pag meron kang sikat ka. Tapos wala pang 3310. 3210 wala pa noon. Makipad. So keypad pa rin siya. No? Wala pang Glow noon. PLDT yun. At saka mga Alcatel, mga Bayantel. Ang mga sikat na telco. Eh di ata sila nag-improve. Kaya natalo sila ng alam na ganun kabilis. Kaya hindi sila nag-improve. Pero binubuhay naman nila ngayon. No, yung mga Bayantel, mga ganyan. Despite of the advancement of Glow and Smart. Okay. Ship keying. So in one baseband or one baseband, you have 4 different messages. Dito nagsimula yung ano. Anyway, frequency ship keying muna tayo. Okay. Now Gaussian, if you are having your higher math, one way to represent or understand the frequency spectra in digital is using the Gaussian. Let me introduce to you the phase shift. So from 0 to 1 and 1 to 0. So from 0 to 1, you will notice there is a 180 degrees out of phase. Ito. From 1 to 0, so you have another 180 degrees out of phase. Okay. So, but the same amplitude. The same amplitude. And then this spaceship keying modified to binary phase shift keying. So basically, you have 2 different data in one carrier. And then you have your quadrature 4. You have 8 yata. 2, 4, 6, 8. Pero it was modified and in a QAM technology. QAM stands for quadrature amplitude modulation. So it is a combination of ASK and PSK so that the maximum contrast between each signal, bit by bit, tri-bit, and so on is achieved. Ayan. So you have 4 QAM, 8 QAM, 16 QAM, 18 QAM, 16 QAM, 32 QAM, 64 QAM, 128 QAM, 256 QAM, 256 QAM, 512 QAM, 1024 QAM, and 2048 QAM. No, ganyan na ngayon ng mataas na ngayon ang technology ngayon. Ayan imagine in one carrier, in one baseband, nakakapag-submit ka ng send ng iba-ibang data, information. Sa 16 QAM lang yan, guys. Ha? Wala pa tayo sa 32 QAM. Okay? So, in summary, so bitrate and baud rate are being compared from the technology of ASK2 up to BPSK until the 256 QAM. Okay. So the baud rate is still the same, but we have the bit rate is N8N. Okay. So these are some examples. So if we have a 8 equally spaced on a circle, if the bit rate is 4800, what is the baud rate? So kasi yung 8 is 2 raised to 3. Kaya i-divide mo siya ng 3. So you have 1600 baud. For the bit rate for a 1000 baud, 16 QAM. So this is 2 raised to 4. 2 raised to 4. So 1000 times 4 is 4000 Mbps. 64 is 2 raised to 6. Tama, 2 raised to 6. 2 times 2 times 2 times 2 times 2 times 2 is 64. Okay. 12,000 naman siya. In summary, these are the technology involved from FM to a technology of PSK in MERI for local area. Ano pa naman ng local area mo? Kasi may limitado siyang 100 meters na kable. Pag lumagpas ka na doon, because marami kang empleyado, so o maraming gagamit ng computer, so you need a buffer para ma-re-amplify ang signal. Yan. Yung mga cellphone gumagamit ng QAM na rin yan. Yes. So, to minimize spectral occupancy, maximizing the capacity in number of users. So, meron kang isang telephone lines, isa lang, binabayaran mo, parang sa bahay, nagpakambit ka ng converge, binabayaran mo isang linya, pero may minimum number of users lang. Okay, pag magpas ka na doon, that's a separate, a different payment. So that's part of business na. Parang sa ano yan, internet, di ba? Meron kang 10 internet user naglalaro ng Counter-Strike. Sabay-sabay sila. Pero isa lang ang telepono binabayaran mo. Isang list line na. And that's the power of the technology of natin, ha? May nakita ko rito. Ito, time division multiplex access. Okay, TDMA. Because of the multiplex, alam ko kung nakarating kayo rito sa logic circuits. Multiplexing, many into one. Sabihin, meron kang isang kalye, may 4 na tao gagamit ng kalye. Magdadali lang sila ng signal. 4, isang tao, ito yung pangalawang tao, ito yung pangatlong tao, ito yung pang-4. Magdadala sila ng message dito sa dulo kay Sir Junto. So ang gagawin ni Sir Junto, sige, kayo, hatiin nyo ang kalye ng 4. Siyempre, ganun magsalita si Sir Junto, di ba? Ayan. Hatiin nyo. Baluktot. Basta hatiin natin sa 4. So gagamit ng bawat isa ng lane. Ayan. Equally divided. So parang ano lang yan. So communication, if this is the bandwidth is let's say 4 times 4, 16. No? 0.323. So 3 lang pala. Kasi ang voice frequency is 3 kHz. So 12. Now divide mo yung 12 kilohertz divided by 4. So meron kang 3 kilohertz, which is the voice frequency. Enough na marinig mo yung signal. Yan. Ang tawag dyan, frequency division multiplex. Iba, ginagawa, isa-isa gagamit ng baseband. Okay? Ito muna. Sige, gumamit ka ng kalye hanggat ang gusto mo at a certain time. At a certain time. Okay? Sabi natin 1 minute. And then, ang personal, number 2, siya naman gagamit. Bahala siya paano niya gagamit yung linya. Basta in a certain time. Ganoon din ang 3 and 4. Ang tawag dyan, time division multiplex. Okay? One example of this multiplex technology, pag nakikinig kayo ng stereophonic. Sa kaliwa, boses na kumakanta. Sa kanan, instrument. Multiplexing yun, guys. Okay? FM station meron nun. AM wala. No. Okay. Kasoy, yung Dota sa isang internet na maraming computer sa internet, no? Maraming naglalaro ng Dota, Counter-Strike, di ba? Isa lang naman ang telephone lines, di ba? Isa lang linya. So dito, kung sinong ready, gumamit ng linya, enter. Isa naman, kung sino ready, enter. Ang tawag dyan is statistical time division multiplex. So through the years, no, nagagamit na siya as protocol, as standard protocol sa pabilis na technology. So these are the advantage as we increase the technology. No, high power efficiency, robust to multipath effects, low cost. No, madali lang siyang i-install kasi. Okay. And okay, so I think that's the end of our asynchronous lesson for digital modulations. Okay. Thank you for your patience. Thank you for listening. And I hope by Monday, despite of the defense again, we could meet. No? The submission of your tuner will be on the term test. No? Or i-extend natin hanggang to the last day of that week. Okay? Yeah, i-notice na lang ako ng inyong presidente na si Lima, tsaka si Ate Abri. Okay. I would like to take also this opportunity that since na Holy Week tayo ngayon, no, sayang naman at why not have a little bit of sacrifices and prayers. So on Thursday, merong alay lakad, or we call it Station of the Cross. For your studies, for yourself, for your family, okay? And of course, we will also pray for the forthcoming elections. Kaya napili natin yung Manila Cathedral kasi ang harap nun ay ang Palasyo de Gobernador kung nasaan ang COMELEC. Okay. So, just contact the officer. Just bring extra shirt, payong. Siyempre, kung kulang kayo sa pera, sabihin nyo lang doon sa mga officer at magawa ng paraan. Okay? 7 o'clock ng umaga sa gate, magkita-kita tayo. God bless you all. Thank you and have a nice day. Thank you.